So we all know that AI is just not about data, compute, or models. It's also about foresight and leadership. We need a leader who can take the wisdom of the godfathers of AI like Yann and communicate and translate it to the entire ecosystem. And who better than our own president of Nasscom, Ms. Debjani Ghosh. I would like to invite Debjani for a fireside chat with Yann on the topic of how open source can drive impact for India. Over to you, Debjani.
Thank you, Madhav, and that was wonderful. Thank you for the talk. You've spent, I think, the last 3 days in India now? Yeah, around 2.5 to 3.
Very late Sunday night.
Very late Sunday night. And I think it's been a whirlwind tour of pretty much all of India. You've been to the south, Chennai, Bangalore, did you go to Bombay? Mumbai, and now Delhi. So my first question is, and I'm sure you've met with the who's who within the AI community of India. What are some of your biggest takeaways? I mean, what was the aha moment for you, and what are you worried about?
Enthusiasm of young people in India for technology, for AI in particular, because AI is kind of the coolest thing you can do at the moment. I was at a hotel in Mumbai Monday, just relaxing in the lounge or something, and 2 separate people came to me and wanted to take a selfie with me, and then telling me, I have a startup on AI and we're doing blah blah blah, and we're fine-tuning Llama and doing awesome stuff. So thank you so much for your position and Meta's position on open source. It's creating an industry, and I see the evidence for that industry in India being really kind of flourishing. I was just earlier today at IIT Delhi, and there was a crowd of eagerly enthusiastic students lapping up all the words we could say. A few days ago, I gave a talk at IIT Madras, and similarly excited population. I mean, people who, I'm sure are very talented. There's certainly a lot of interesting research coming out of Indian universities and labs. I think, and so that's the hardest thing to get, is a educated, talented population. And at least at the undergrad level, India has a good handle on this. What's missing a little bit is 2 things. A motivation for young people, talented young people, to pursue graduate studies on the topic, not just masters, but also PhDs. And too often in India, that's done abroad. And too often they don't come back. So giving opportunities for young, ambitious, talented, future aspiring scientists to pursue graduate studies in India and stay in India is important. And for this to occur, young people need to have some hope of a fulfilling job in research in India. So right now, the choice for this is fairly limited, and I have personal experience with this because I was in the same situation 40 years ago in France, okay, where you can certainly go to academia, but that's a particular choice that is not appropriate for everyone. You can do a startup, you don't necessarily need to do a PhD for that, although it helps. But other opportunities are research positions in industry. And that is very rare in India because companies in India are not actually, don't have it in their culture yet to do research in the style that is done today at FAIR or at Google Research to some extent, at Microsoft Research in the recent past, and then before that at Bell Labs, Xerox PARC, and IBM Research. Okay, there is this tradition of doing ambitious research in industry, publishing it, not being too possessive about IP, not being too secretive, and that culture does not exist very much outside of the US. Even in Europe, you don't have that very much. So the best industry research lab in Europe are all American companies. They're basically Meta and Google, and a couple others. So that's kind of missing in India. And the importance of this is that if you have this prospect for career for young, talented people in India, they will stay in India. They will do a PhD, they will stay in India. They may not get a job at the top research lab, but then if that doesn't work, they'll do a startup or something. That will lift the ecosystem. Now, I speak from experience here, because 9 years ago, we created a branch of FAIR in Paris, which has now about 100 people. FAIR, total around the world, has 500 scientists and engineers in 7 sites. The 3 biggest sites are in Paris, New York, and Menlo Park in California. The 4 smaller sites are in Seattle, Montreal, London, and Tel Aviv. And we have tiny ones in a couple other places. But the existence of FAIR Paris basically put in the mind of young French students and European students, like, I can have a career in research and not necessarily be a public servant in a university, because that doesn't fit everyone's desires. And as a result, not as a result, but one thing that we did also at FAIR Paris is that we have a program of hosting resident PhD students. So at any one time, FAIR Paris has 40 to 45 resident PhD students that are co-advised by someone at FAIR and someone in a university. And so a PhD in France is 3 years, because you have to do a 2-year master's before, and which means we're graduating about a dozen PhDs in AI every year. And basically that just totally jump-started the ecosystem in France. And now Paris is the hottest place for AI startup outside of the US, essentially. So that template could be applied to India.
No, I think you've gone to the heart of the problem. And it's absolutely one of the biggest concerns we have, which is how do we, as you rightly said, we don't have the mindset for hardcore R&D in India. I mean, it's surprising to see that all the people who are really building AI, whether it's Llama or you look at any company, are from India, mostly, right? And it's something for us to really think about, is how do we ensure we create an environment where they stay back and they can build these wonderful technologies in this country. So I think that's a very astute observation. So let me switch tracks a little bit. Right now we are living in a world where there are almost 2 parallel truths coexisting. On one hand, everyone believes that AI is the best thing possible. It's one of the biggest transformative forces, and that's absolutely true. On the other hand, there's also increasing concern about the ROI. Given the investment that we are making in AI and the investments are mind-boggling, where is the ROI? And will we ever see the ROI? And I think both are correct in a sense. So where do you stand in this debate, and what's your take?
So it's very difficult to estimate what is the reasonable level of investment in AI technology. I mean, certainly there are, we hear, I guess there is a famous phrase used by a former director of the Federal Reserve, irrational exuberance, right? And he was talking about a stock market bubble, basically, or real estate bubble. I'm not saying there is a bubble in AI. There's certainly a very high level of investment, because a lot of companies have a fear of missing out. A lot of investment companies have a fear of missing out. And so a lot of investment are going to a lot of companies. I think at some point we're going to see a bit of a more sort of realistic renormalization of the fact that a lot of those companies probably are not viable, or maybe are viable but not at the level of spending that they are currently doing. Like, for example, some companies have been formed with the idea of training their own foundation models. And I think it's personally that it's a very difficult thing to do for a company that doesn't have a large source of revenue from other sources like Meta and Google or Microsoft. If you're a startup and you want to be at the top level to train a foundation model, you might raise $1 billion, but you're going to run through this $1 billion in 2 years. And then are you going to be able to generate the appropriate level of revenue that justifies your valuation within that time frame? Not clear. So, you know, I have a lot of friends running those companies. I don't want to discourage them. I don't want to say that they're going to fail. But certainly there is, you know, some sort of estimate to do there. What a lot of people are finding is the same thing. It's the same scenario that occurred in AI in the 80s and 90s, the late 80s, where in the 80s there was a lot of excitement about rule-based systems, expert systems. And, you know, the hardest job was going to be knowledge engineer. You were going to sit down and talk to human experts about medicine or computer systems or whatever, and then reduce all that knowledge to a bunch of rules and facts, and then feed this to an inference engine that would be able to kind of solve problems for people. And that turned out to be partially true, but also extremely difficult and expensive to do on a case-by-case basis. So reducing the human knowledge to a bunch of rules turned out to be almost impossible most of the time. And for the situation that for which it was possible, it was expensive, which means the number of applications, the size of the market for this was much smaller than people envisioned. And so most companies went bankrupt. They worked for a while and then they went bankrupt. Companies that built hardware for this AI system, Lisp machines, eventually went bankrupt in the early 90s. So you got to be careful, right? Reducing to practice, making systems. You know, the similar scenario that occurred with autonomous driving, where 10 years ago, people were super excited. You know, there was demos. You know, you could train a neural net to drive a car for 10 minutes on complex road, and that was really impressive. And you had lots of demos like this, lots of companies that were created around this idea, and lots of even amateurs who would do this, right? I mean, it was kind of relatively easy to do. But then what was hard, and we knew that, was that to make those systems sufficiently reliable that you can actually deploy them is really, really, really hard and expensive and requires enormous teams of engineers and to take care of all the corner cases and everything and productize it. And as a result, there's only a handful of companies that can do this today, right? It's Tesla, NVIDIA, and Mobileye, and a couple others. NVIDIA works with Mercedes, Mobileye works with BMW and other companies. And then there are separate companies that work on robotaxi, and that's a completely different set of technology like Waymo and Cruise. They don't actually use the same kind of techniques. They need the environment to be completely mapped. They use sophisticated LiDAR sensors and things like this, and they engineer everything out of it. And so it's not really practical for like a consumer car or anything. So those things turn out to be more difficult than you envision from an impressive demo. And there's a lot of that going on in AI. There's kind of a similar story for IBM Watson. Remember IBM Watson? So IBM Watson was going to be deployed in every hospital. It was going to help doctors. Yeah. That turned out to be really difficult. Yeah. Like just productizing that, making it useful, reliable. And that business essentially failed, and IBM sold it for parts and is not doing it anymore. So, making a product out of an impressive technology is not simple. So what I'm counting on, so companies like Meta and Google, have enough funds to kind of keep funding this for a while. At some point, they might get tired if we don't make significant progress, which is why we have a pretty aggressive plan for, the next generation AI system.
Is there a plan B? Do you all have a plan B?
It's hard enough to find a plan A.
Fair enough.
Okay, I mean, we have two plans. We have A and A star. Okay, as I said, we have a short-term plan, which is just keep improving the current paradigm, right? So LLM with, flourishes and decorations on top of them to help them kind of, for current use cases. And then other things like, image and video generation, audio generation, image recognition, interpretation, video, etc. The long-term plan is more of the type that I was talking about with those JEPA architecture systems that really can plan and reason. It may fail.
So on that note, since we have a lot of founders here, And I'm sure all of them are dreaming to become the next big thing in AI. How do you disrupt? What's your advice to the founders who are trying to build their companies, who are trying to find their niche? What's the secret sauce to differentiating in AI, to building your moat without having to burn the kind of dollars that big tech is doing?
Okay, trick number one, use open source engines. Because you're not going to train your own foundation model if you work in the context of language, right? If you work on other things like AI for science, for materials, for for image understanding analysis, etc., you don't need an LLM. You need other foundation models, and we have them now, and Meta is also producing them. So we have a system called SAM, Segment Anything Model, and that system, basically, you feed it an image, and it can basically delineate every object in that image, and you can control it in some way. That's really useful for a lot of applications in biology, in environment protection, in medicine, in all kinds of domains. There's another system called DINO, D-I-N-O, DINO or DINO, depending on which side of the Atlantic Ocean you're on. DINO V2 in particular, and that's a generic feature extractor for images. So if you have, I don't know, a quality control, you need a vision system that can tell you, analyze satellite images or tell you whether a thing that you just produced in your factory looks good or not, or is defective or something. You can just run Dino, extract the features, and then train a very small classifier on top with very, very little data to actually get the result you want. So that really, really simplifies the construction of computer vision systems by reducing the amount of training data you need for that. So, use all the tools at your disposal, and don't try to build everything from scratch and just profit from open source. That's trick number one. Trick number two, I think a lot of the business is into customization of things like LLMs or other systems for vertical applications. There's a lot of work to do there. A lot of companies that know they want to use AI but have no idea how. And so there's a whole ecosystem of startups that basically cater to those kind of needs, right? That's really the type of ecosystem that open source platforms really enables, right? And everybody I've talked to here who is a founder or member or engineer in a startup, they all use open source platforms. Most of them use Llama. Many of them use Dino or SAM. Yeah. All the ones I talk to in Europe also are based on this. And increasingly, a lot of large companies do this. I was at the Infosys headquarters yesterday, and they use Llama for all kinds of stuff for their clients, big companies.
Oh, absolutely. By the way, if any of the founders have a really good question to ask, let me know. I'll be happy to take one or two questions if time permits. My last question to you, Yann, is as you think about the next 10 years, what do you look forward to the most? What excites you? As you rightly said, I think AI is still in an evolutionary stage. There's so much left to happen. We've been hearing about agents, etc. So what is that one breakthrough that you're really watching out for, you're really interested in?
That breakthrough is this type of architecture I was talking about, the JEPA architecture, systems that understand the world, can plan, have persistent memory. This is the mission of FAIR, right? We have a few hundred people. Not everybody at FAIR works on this plan, but we basically have a few hundred people kind of focusing on making this work. And the potential success of this is really what excites me most. I'm really a scientist at heart. I do technology policy and stuff like that as a hobby, really. And some people in policy at Meta don't like me very much for this, but I think it's an important hobby. Don't misinterpret what I said, but really I live for scientific progress and research, and also for the applications that can result from it. But I leave that to others very often. The very frequently in my career, I had the opportunity of, there was some scientific breakthrough, and there was an opportunity of, okay, let's do a startup, or let's work on this set of applications of this new set of machine learning techniques. And every time I kind of participated in this a little bit, but then came back to the main road, which is making machines more intelligent, right? That's really what drives me. And I'm almost as excited, probably even more excited now than I was when I was 25, because of the prospect of perhaps seeing the light at the end of the tunnel of human-level AI. I think that's an incredibly...
you do see the light at the end of the tunnel?
Yeah, because we have a plan. Like we know what to build. We know it's going to be hard to figure out the details of how to make this work. But we have some idea of an architecture. I actually wrote, and all of this is public, so I wrote a long vision paper that I posted 2.5 years ago. It's called A Path Towards Autonomous Machine Intelligence, 𝐀𝐈. Now we changed the A to advanced because autonomous scares people. But basically I explained, here is where I think AI research should go over the next 10 years. And you're welcome to join us. Like, this is no single entity as big and prestigious as it is has a monopoly on good ideas. There's a lot of problems that we have to solve to make progress there. And so basically that's an invitation for the entire scientific community around the world to collaborate on this. And it's kind of succeeding in some ways. A lot of people are working along the same ideas. But of course, people have their own ideas, and they should explore what they think is most promising. So this is really what excites me the most today. And then on the application side, the potential applications of AI in science and medicine, I think, are enormous, and I'm really excited about this. So I participate in this a little bit, but not to the same extent.
Yeah, no, absolutely. Any questions in the room? Ankit, you have to give me 5 more minutes. I hope that's okay. So I am going to start with you.
Hi.
Short questions, yeah?
Yes.
So I can at least take 2.
Okay. My name is Aditi Agrawal. I'm from Hindustan Times. I'm a journalist. You said something very interesting, that outside of Microsoft, Google, and Meta, or the big tech companies as they're commonly called, it'll be very difficult for someone to to keep investing regularly and to be able to sustain it without alternate sources of income. And earlier you had talked about how there's a need to disperse the training services, the training processes. So who sits atop? And I will mention the G word, which is what happens.
Short question.
How do you prevent yourself from becoming a gatekeeper then? Because that's a problem that
I'm going to take 1 or 2. Any founders? Okay, go ahead.
Hi, I'm Kanish Kaur. I'm founder of a cybersecurity startup, and I solve cybercrime for a living. In India, we face a lot of cybercrime. A lot of us have been victims of digital arrest. Money goes out from our wallet. We're trying to use Llama to solve cyber. Do you think there is more that could be built on Llama on solving the cybercrime issue, which is now impacting everyone, impacting even the common man? Thank you.
I'm going to take 1 more founder question. Yeah, go ahead. And then.
Hi, Yann. First of all, thank you for the inspiring talk. I'm a sophomore. I'm probably one of those guys who's going to come up to you and tell you that we use Llama. Thank you for keeping it open source. You talked about the 4,000 languages that you're trying to, the cultural barrier. I hope you included some of the sign languages also. I have an assistive tech startup. There was a published paper recently about sign LLM, which was creating sign languages from speech. The most important thing, or that LLM struggle with, or generative models struggle with, is hallucinations with facial expressions and hands particularly. Do you think it's a data problem or a time problem?
I think it's an architecture problem. That's an easy answer. So I think, as soon as you have images, those autoregressive LLM architectures that tokenize the world basically don't work. You need to have those JEPA architecture. There are the things that work the best for video and images, but they're not yet widely available in open source form that you can train your own model yet. That's going to happen within the next year or 2.
Any answer to the first question on cybersecurity?
So previous question, cybersecurity. Okay, I have a terrible confession to make. I know absolutely nothing about computer security. This is a part of computer science that I've completely ignored, okay? So I'm probably going to say something stupid. So there was a lot of fear early on that LLMs would be able to be used by nefariously, people with nefarious intentions to kind of break into computer systems and stuff. We haven't really seen this. I mean, I don't think those systems are particularly good, but they're good for defense. And in fact, that's a general thing. Whenever a piece of new AI technology can be used for nefarious purpose, the countermeasure is also in the same technology. And so basically it comes down to, do the good guys have better AI than the bad guys?
Okay, I've been allowed for one more question, so yes.
Okay, this is the first question that I didn't answer. Safekeeping. Gatekeeping, yes. Well, so I talked about open source, right? I mean, open source is the solution, the antidote to gatekeeping. But countries and regions need to have computing resources, cloud service that are AI focused. And it doesn't exist yet in India. Maybe a few large companies will invest enough to do this. It's the same in Europe. I mean, Europe is wondering what to do about computing infrastructure for the same reason. So I think it's going to happen. And I think when that happens, then those open models can be trained in a distributed fashion. And regions will control their own data. But then in the end, we'll have super models. That's maybe a bad word, but models that take into account all the data around the world, and basically those distributed training will arrive at a consensus model that is good for everyone.
Quick question, please.
Yeah, sure. Thank you for being here. I'm Amit Shrivastava from Confluence AI. I'm one of those founders who works on images. So I've been hearing a lot about energy-based model. And do you see that happening? And what is your advice for startups? Should we look at probability-based model today and let that energy-based be in academic, or we should look into it?
Okay, so energy-based models.
One more question, Yann, and then you can answer.
Okay.
The gentleman, I know you've been putting up your hand for a long time. Please go ahead.
Hi, I am a founder of an organizational psychology company, so I have a neuroscience-based question for Yann. How can AI be used to help human beings reach their peak potential, especially the psychological potential, in things like learning, behavior change, employee motivation, and leadership?
Thank you.
Okay, education, basically.
Psychology at workplace.
Mental well-being.
Mental health. Okay, so there are a few companies that I know of, startups, that actually are interested in mental health. So it turns out it's relatively easy to talk people out of committing suicide, for example, with a chatbot, strangely enough. Okay, this is not something that Meta wants to do because it's perceived as intrusion. Okay, but there are companies that work on this. I think it can be very effective. There are companies around the world, particularly in countries where it's very difficult to get an appointment with a doctor, and there is some stigma with mental health, so people don't want to see a psychiatrist or something like that, where basically you have LLMs that can provide health advice. And it turns out when those systems are available, people are more willing to tell them their problems than they are to a human doctor. And so there's this curious effect that in countries where it's very difficult to have a doctor because, so the example I'm thinking of is from a colleague of ours that has a company in Senegal called 𝐀𝐈 𝐂𝐴, and he's built LLMs to basically provide medical advice. In Senegal, I think there are 5 doctors per 100,000 inhabitants, and they're all in big cities, so if you are in rural areas, you basically can't see a doctor. But you can talk to the medical assistant, and that actually turns out to be really useful. I imagine there are similar solutions in India that would be useful as well, if you can get over the regulatory hurdles, which apparently less of a problem in Africa.
I think we can't take any more questions, but you had asked about energy-based models, right?
So energy-based models. So this is basically a theoretical framework or a concept for understanding certain types of learning. There is the classical framework for understanding learning is probabilistic estimation. Okay, so you train a machine learning system to estimate the probability that one particular answer is correct. And of course, if you cannot exactly predict which answer is correct, so which word comes after the text, for example, you produce a probability distribution over the words or over the tokens. Now, it turns out for data like images or video, this is not practical because we have a hard time representing normalized distributions over the set of all possible images. We don't know how to do it. We hit computational intractability issues. And so their energy-based model basically is a way of essentially getting around that problem of modeling normalized distribution. This is a little technical. I apologize for people here for whom this is like I spoke in Sanskrit or something, but that's the basic idea. So it allows you to understand what you're doing, basically.
So with that, the evening's not yet over, but thank you so much, Yann.
Thank you.
For being so generous with your time and your knowledge, and I think it's given the number of founders in this room, I think that'll be really helpful. So we do hope you'll come back again. You can see how interested people are to speak to you, so I do hope the frequency will increase. But thank you again for an absolutely wonderful conversation.
Thank you so much.